Hello everyone! Today we're going to look at the software that helps Gandalf decide who shall pass. Okay, you probably wonder, what? And I agree. It sounds confusing, so allow me to explain. I have a simple web app that talks to the API, that talks to the database, and then bubbles up back. Today we're going to look at this software, see where we can test, and draw the brick by brick every type of test on the test pyramid picture. At this point I used phrase test pyramid, and sometimes it's also called a test triangle because it's actually flat, but I didn't really explain what it is. If we look at this picture, we can see that each layer represents different type of tests. Surface area is a visual representation of how many tests should you have on this layer. Another important note here is that the tests on the higher level are slower and less reliable than tests on the lower level. Have you ever had this UI flaky tests that sometimes fail randomly? Sure you did. We all had this experience. So based on this slow versus fast logic, we want to have as many of the tests on the lower level, a few in here on the integration level, and just a handful on the top. Another important thing you need to remember is that this is a model for automated tests or test automation. It is not a model for testing as an activity, just to decide where to test when you're writing tests. Let me explain how the system works from the user point of view. This is our website. It asks for your name, you enter your name. So for example, Frodo. And when you click search, the request to the API being sent, and the API responds if you pass or not. And results are displayed here. For example, if Frodo wants to pass again, it doesn't quite make a lot of sense. So he is stopped, and if someone not from the fellowship want to pass, so they are not allowed to. Those three scenarios when I touch the UI of the website could be automated using one of the UI frameworks like Selenium or Cypress. If you want to know how to write a Cypress test, check out this video that's gonna pop up here. Also note that I only performed just 3 tests. A lot of the times this is enough to prove that system works when all parts of it plugged in together, which is a purpose of end-to-end test. It doesn't mean that it's going to be all the testing that we should do, but this might be enough from the high-level end-to-end perspective. Let's add our first brick to the pyramid. What we did is we used the browser to perform our test. So the request went from here into the API and then into the database and then back, and results were displayed. So I'm going to add the first brick here, which is test via UI. Note that there is a subtle difference between testing via the UI and testing the UI. One more thing, by performing this end-to-end test, we have indirectly proven that the UI can reach the API. So I'm going to draw another brick here for the integration. So it's a UI API integration. Now, imagine there is no UI. We still could hit an API directly using Postman or any other HTTP client and get a response. So we could just do something like this, right? And this test could also be considered an end-to-end test from the API perspective if you are deliberately testing your system via the API. Maybe it also could be an indirect proof that the integration between API and database is working. So I'm going to draw 2 bricks here. We looked at some pretty pictures, and now it's time to look at the code. reminding you that our website looks like this, and this is the HTML code, which is pretty simple. Your body basically have a label, an input, a button to submit what you have inputted, and the div placeholder for the results. So this button calls this JavaScript. It could be slightly challenging to actually test HTML, but it is possible even if you use vanilla HTML without any frameworks. Let's have a look. Here's our HTML code, and here I have an example of the unit tests that test specifically this HTML code. Let's have a look at them. You see that I check that my file have a form element, that I have an input, that I have a button, that this button have certain attributes, and that this button can call submit search function. You could say that we have unit tests for HTML, and this little test is slightly more special. It's almost a proper integration test that this button will be having this on-click attribute, and it will call this function, and this function is actually exported from this file. Of course, to properly test it, you will have to fire a proper event and mock that submit search function has been called and ascertain that, but for our exercise it's enough. So now we're ready to draw two more boxes on our map. Box number 1 is a HTML unit test. Box number 2 is a HTML calling JavaScript integration test. If you looked closely, you would have noticed that those tests were only applied to HTML code, but frontend also have a JavaScript code associated with it, and this code also has to be tested. Most of those functions there need to be unit tested as well, and if you do that, you'll have another box here, which is just JavaScript box. Moving on to the API side of things. As you can see, this endpoint of this API doesn't have much logic, but it still could be tested, and I have an example of the tests here. So, for example, I could test that there is a shall you pass endpoint, and that there is another endpoint which returns 404 for random, and then I have some tests to assert on the actual response of the API. Reminder that we already have these boxes for these API tests already on our picture. Moving on deeper into our software, you can see that from our API endpoint, all of our logic actually happening in here in the business logic layer in this shall you pass function. So normally this is where you would have the majority of your unit tests or even integration tests. Here is an example of the test you could write for the business logic like that. You can see that I test the belongs to fellowship function, which returns true or false based on the name passed, and shall you pass function. If you look closer to the actual implementation of one of them, for example this, you could see that we just have a regex which checks against the input body and then returns true or false. If you want to learn more about the regex, check out the video that's gonna pop up over there. Also pay attention that here I have a special test that check if I have called the database or not, making this an integration test. So now it's time to draw two more bricks for unit and integration tests for the business logic layer. So we have a brick here for business logic plus database, and we have a brick here for business logic. Database layer is code again, so the same logic applies. You would have to write the test which tests those functions, and you would have unit tests, and some of them will be an integration test because it's checking that your database access layer can talk to the database. More bricks to the picture. Last layer we didn't really talk about is static analysis. It probably deserves its own video, so I'm only going to do the high-level explanation. If you use an IDE, it is actually pretty smart and complains about things that you should not be doing. For example, you can say var my var, And you can see that IDE highlights it because it knows that in the modern JavaScript, you should be using vars. This is an example of a static check. IDE is not the only thing that can help you with that. Normally, people will use extra help from linters like ESLint or Prettier. If your language has a compiler, that's also a good static analysis test. Can it compile, and are there any errors thrown or warnings? If I were to draw that, I would draw multiple bricks over here because there's like a big amount of checks that is going on normally, and that's like a foundation of our test pyramid. We spent quite a lot of time drawing the bricks, but never actually reflected on why do we need to be doing it? Why we do so much effort and have tests on so many layers. Imagine two situations. On the first one, you have a lot of the UI tests. So you have a website with those tests, and one of them starts failing. Now, to figure out what's wrong, you will have to look at the results of the test, and then you will have to kind of use your brain and dig deeper into this layer and walk around what could go wrong here, right? And then maybe it's not this one, so you have to go deeper and search more. So if you're lucky, it's going to take like a minute or two. If you're unlucky, you might spend like half an hour investigating, trying to find root cause of the problem. Second situation, imagine you have a proper pyramid with just a few end-to-end tests and a lot of tests on the lower levels. So imagine that your test failed, and you would normally have another test on this layer that failed and another test on that level that failed. So you can just trace down to the source of the problem normally and just fix the root cause. Of course, it's a good practice if your end-to-end test fails and you have no lower level tests that fail to add them so that next time you're going to be safe. We have tested a lot and we tested on different layers, but it still doesn't mean that we have tested enough, that our product has no issues and that our customers are going to be happy. Test coverage is a big lie, but this is a topic for another video. See you next time.